Hey, I'm Rob Barnes. I'm a senior developer advocate here at HashiCorp, and I'm also joined by Nick Jackson.
That's me, Nick Jackson, developer advocate at HashiCorp too.
Welcome to the first of two sessions that Nick and I are doing here at HashiTalks Secure. The sessions that we're doing are going to be centered around Boundary and integrating that with Nomad. And in this session, we're going to focus more on the Boundary side of things. If you've never heard of Boundary, Boundary is a session access management tool. We're going to deep dive into what some of the problems are that we face as engineers and how Boundary can solve some of these problems for us. So let's look at this in practical terms. So here we have a very typical setup that most engineers would have encountered. We have a couple of private subnets. We have workloads within those subnets, and because they're private subnets, we do not allow any ingress into these subnets, which is fine. And as engineers, we probably should not have access to production workloads that are inside these subnets until something goes wrong or until we need to perform some sort of task as part of our role. Now, the way that we typically do this is we use constructs like a Bastion host, or we use jump boxes, or maybe something like a VPN. If we start looking at, say, the jump box example, we can look at some of the challenges that are involved in that. So the way a jump box normally works is you have a machine which is within that private network, and there is an ingress allowed onto that VM. The idea is that you can, SSH to the VM, you can authenticate, and then once you're on the VM, you're now within the network and you can jump from that machine to your target workloads. Now, the challenge with that is in order for me to authenticate to that jump box, we typically use things like SSH keys. Right? So we'll place our SSH key on this jump box, which means that we can make our SSH connection to the jump box, and that's our authentication complete. And now we can jump to our intended target. But that lifecycle of the SSH key doesn't always tie to the lifecycle of my employment at the organization, for example. So anyone that's used this approach before, I'm confident if you go to companies that you worked at many years ago and your SSH key has not changed, you probably still have access to their production networks. Right? So we have this challenge of managing the lifecycle of the identity that we put in the form of the SSH keys, and tying that to the life cycle of our employment at an organization. The second big challenge that we have is once I'm on the network, if there are workloads within that network that I'm not supposed to have access to, there's nothing preventing me from jumping from the jump box to these targets that I should not be going to, right? So when we think about the principle of zero trust security, we have to assume that our networks are already breached, right? And that by the very premise of me getting onto the network via a jump box, that's me breaching the network. Because even though I typically could be a trusted individual, this is a very high trust approach, and this is not the approach we want to be taking. If I become a disgruntled employee, I now have the ability to jump to targets that I shouldn't be able to get onto and cause mayhem, which is some of the things that we need to avoid. And that's even a malicious thing. Sometimes it can be as simple as I've jumped to the wrong box and I'm doing something which is intended for another box, and it ends up causing disruption. So we need to put a model in which is zero trust rather than high trust. And with bastions and jump boxes, it becomes very difficult to implement this way of working. So if we look at how Boundary can help us solve some of these challenges, here we have a basic overview of our demo architecture, right? And we'll walk through this, and as the demo goes on, Nick will do a demo. You'll see how Boundary can solve some of these problems for us, right? So Boundary is made up of two components. We have the Boundary controller and we have the Boundary worker. Now, the controller is the brains of the operation. It's the thing that as a user I authenticate to, so it will manage all the identity and so on and so forth. It's the component within Boundary that will decide whether I am authorized to access a target. So it does the whole access control part of the model, all within the controller, right? And then when I want to create a session to a target, the controller will also schedule that. But when we say scheduling, it schedules a worker, which is the second component. So the worker does all of the heavy lifting of, the proxying and the tunneling between your private networks and the machine that you're trying to access it from, right? So in my case, it would be my laptop, right? So those are the two main components of Boundary. So if we look here, what we have is we have our controller in HashiCorp Cloud Platform, or HCP. And the nice thing about that is now I don't need to manage this controller. I don't need to do any upgrades on it. I don't need to manage operating software upgrades and so on and so forth, all the patching. That's not my concern. HashiCorp will take care of all of that for us. So that's all managed within HCP. And then what we do is we install we add workers to all of our private networks. And these things will connect back to the controllers in HashiCorp Cloud Platform. So if you look at our diagram, we have 3 subnets here. We have a front-end subnet, we have a back-end subnet, and we have another subnet, which we're calling Vault, right? These are all private subnets, so they should not have access to the public internet. Right? There'll be firewalls in place to make sure that from the public internet, you cannot access things within there.
So I think Rob has really sort of eloquently explained the problem that we have. So let's kind of start digging in and let's look at some of the solutions. So what I want to kind of show you in this demo is how we can connect to virtual machines using Boundary and Boundary HCP. And this is kind of the setup that we're going to have, because I think there's a way that Boundary works. It's got a very, very elegant solution to the problem of ingress into those private VPCs. So we kind of already explained that we were going to use the HashiCorp Cloud Platform. And the way that that works is you have the Boundary controller and you also have a number of workers. Now, the workers are the things which broker the connection. So they handle that connection and they send it on to the destination. The problem that we have in our setup is that our kind of VPCs, our front end, our back end, and our vault, well, they're all private. There is no ingress rule into these VPCs. And we certainly don't want there to be, right? We want to kind of keep things as very simple as possible. So the way that we get around this with Boundary is that we use this concept of a private worker, which you can see here deployed in each of our VPCs, and multi-hop workers. And what they actually do is they punch outwards. So the private worker here in front end is going to make an outbound and egress connection to the public cloud worker, which therefore allows us to have that tunnel inwards, right? And it kind of works very, very elegantly because configuring those egress rules is a lot sort of more straightforward than having to have sort of a lot of the public ingress and from this, and it's just going to confuse things. And you're going to see how brilliantly this works. So anyway, enough talking. Let's get into the demo. So if we look at the configuration, and this is just an example configuration here for Boundary, we're going to kind of go through and we'll generate this from a script. But this is our Boundary configuration. Now, as a very basic Boundary configuration, you need these 3 sections here. So we need the cluster ID. And the reason we need the cluster ID is because we're using HCP. Now, you could use OSS Boundary, but to be honest, the capability around using the multi-hop workers that we kind of just talked about and showed in the diagrams there is fabulous. And HCP Boundary, you can get a free trial, and it's just so much nicer as a kind of a use case. It means we have to configure a heck of a lot less. The other benefit of using HCP Boundary is you don't need to specify the location of your boundary control plane, your boundary cluster, because when you're using HCP, it just knows where all of that is. So what we do is we give it the cluster ID. Now the kind of the cluster ID is exactly the same ID. You probably can't really see it here, but it's it's in the URI there of my boundary HCP user thing. So we're gonna set that. Now I'm not going to paste this in at the moment, but I'll show you how we're going to set that in a second. And then what we're also going to do is we need to specify a listener. So the listener is the address for the worker where it's actually going to listen to, and this is so other workers can actually connect to it. In our instance, we actually can set this to just be localhost because we don't want any other workers to connect to it. But we specify the address there, and we have to specify the purpose. Now, the kind of the boundary CLI, or that we're going to use, the boundary command, actually has the capability to run as a control plane, as a worker, various other different bits. Now, we're just going to use worker, so we set the purpose here to proxy. Then we've got to specify some of the worker configuration. So the worker configuration is specified here in this worker HCL block. We're going to give it the auth storage path, and I'll explain what that's going to be in just a second. We're going to give it an activation token, a controller generated activation token, and some tags. Now let's break this down. So when you're authenticating to Boundary from the worker, there are two different approaches that you can use to authenticate. The first one is controller-led. And with controller-led, what you do is you generate a token inside of the boundary control plane, and you give that to the worker. The worker uses that token to do the initial authentication to Boundary, but what it does is it swaps it for an authentication payload, which contains the actual authentication token and also the certificates that are needed to connect to the boundary control plane. So it's going to automatically configure itself with TLS. It stores that information inside of auth storage path. So in theory, you got to remember is that this activation token here is one shot. It's single use. So if your worker restarts, then it can't use the activation token again. So what it's going to do is it'll fall back to reading the authentication version data from this auth storage path. So the auth storage path needs to persist as long as your worker wants to hang around. So if you're going to write this to temporary storage and you restart the temp folder, or you restore it to like a RAM disk and you restart your VM, when the VM comes back up, the worker is not going to be able to re-authenticate. So that needs to be persistent storage. The other thing to remember about this storage is it contains the authentication data for your boundary worker, so it needs to be secured. The only thing that should have access to read from that is going to be the boundary worker. So it needs to have the correct file permissions and file paths that no other applications or processes on the machine can actually read from that and potentially cause you a vulnerability. The tags, what we use the tags for is whenever we're creating a target, and we'll kind of look at this in a bit, we can actually specify that this target is linked to a particular, or can be reached by a particular worker. And that's why we're going to specify the tags here. So we're specifying this as front end, and this worker is going to be able to service any of our front end applications. So that's the worker configuration. Now what we need to do is we need to generate this. Now there's a kind of a number of steps we need to do. So first thing is we need this controller generated activation token. Now the controller generated activation token we can actually generate just using the boundary CLI. So we can use a command like this. Now we're going to do boundary workers create controller led, and it's going to generate as a token. Now, in order to do this, we've got to be authenticated against the boundary control plane. So I've already authenticated, and I've got my authentication token here in boundary token. But we'll get into this when we start putting the script together. We also are going to need to manage that authentication. So let's just run this to see how it works anyway. So you can see there that's going to give me back an activation token, and then I can use that inside of my configuration file here to do the authentication. So that's kind of like on the face of it, right? That's fairly straightforward. But we do need to actually authenticate first. And to authenticate, what we can actually do for a machine is we can just run the boundary authenticate command. So the boundary authenticate command, we're going to use the password. So inside our boundary organization, I've got this one here set up as HashiCorp. I have I can configure users, and I can configure groups and roles that have access. So we can kind of use that to register our worker. And you can see here, actually inside of the CLI, this is the worker that's just been registered from the command line. Because what's important to remember is that when you execute the command to create a worker, it generates a token. It also sets up the worker in a stub in an unconnected state inside a boundary. So obviously it's never last seen. It doesn't have a release because the worker hasn't connected. So I'm just going to clean this up and remove that. And we'll come back to that in a little bit. So let's go through. Let's build an authentication script that we could use from systemd or another sort of init process, which is going to authenticate our boundary worker. So I'm going to create a startup script here. And in the startup script, it's just going to kind of use bash. I'm using -e there for error correction. But let's add some variables just to kind of set things up. And we can define those variables here, right? So what I'm doing is I'm gonna need to make this script somewhat dynamic. Now, so I'm going to configure it from environment variables. So I'm going to have environment variables on the machine, which I could set with cloud in it or whatever, to be set to the worker name, the cluster ID, the username, the password, and then importantly, I need to set the authentication method ID. The authentication method ID is going to be different. You can have multiple ones of these set up because in terms of the way that kind of boundary works, you've got the ability to have obviously your organization, and then inside of organization we have projects. So there's a kind of a number of different ways that you can kind of configure the user access. Then I need to set my base URL because I'm going to use the boundary API to do all my authentication and stuff like that. So I'm going to set that. It's very formulaic if you're using HCP. It's always going to be your cluster ID.boundary.hashicorp.cloud, and then your auth URL, which you can use, and we'll see how we do that, is basically the base URL / auth methods, the auth method ID, and then the kind of the control that we want to invoke, which is authenticate. So once we've kind of got those variables set up, then what we can do is we can actually do the authentication itself, is this command here. So let's have a look at this. So I'm just echoing what's going on so we can see for some debugging. And I'm going to generate an auth request. Now boundary, the kind of the API, you're going to post it a JSON payload. So in the instance of the authentication, I'm going to post it a JSON payload, which has a top level of attributes, and then it has a login name and a password. And this is going to be the user inside of the boundary authentication there, which is set up there. That's going to return me some information. Now, if I kind of do the authentication manually, let me just kind of show you. Let me just redo that. So let's just have a look at this as if you were going to return it as JSON. And you can see there that it kind of returns you a JSON payload. Let me just make that a little bit clearer and really? Let's return that JSON payload and let's pipe that in a JQ. So you can see there, this is the data that's going to come back from boundary. There's a lot of editing that's going to need to go on here. And we get the token. So we get the token there. And what we're going to do is we're going to use sed, and we are going to parse that out. And we're just going to grab that token and we're going to store it in a variable. Now, if you were using JQ and you had JQ installed on your machine, then you can make that easier. We're building this script up using sed because it's pretty much got the lowest common denominator of all of the software that could be installed on a base Linux instance. So once we've grabbed that authentication token, we can use that to generate the controller-led token. So the controller-led token is going to look like this. So again, we're making another API call. This time we're making that call to the token URL, which is boundary v1 / workers create controller-led, as you can see here. And what we're going to do is we are going to use the bearer token header, passing the token that we just created from the authentication request. And we're going to generate our controller-led token. Now, our controller-led token allows us to specify some criteria, such as the name of the worker, which is really nice rather than it being random assigned. So we're going to set that as a payload. We're always setting the scope ID to global because workers are always attributed to a global scope, regardless of the number of projects and things you've got available to you. Is that true? It is true, isn't it? Anyway, and then we're going to specify the name. And the name here, we're just setting from a variable. That again is going to generate us or return us a JSON payload, and we're going to use sed to get that activation token out of there. Now, the worker ID is also returned from that JSON payload, and the reason we need to store the worker ID is that whenever we deregister the worker, so whenever the systemd job shuts down or we want to deregister the worker because we can create these semi-persistent workers now. So we're going to grab that and we're going to just dump that in a file. So the next thing, once we've got that controller token and the ID, what we can do is we can actually generate the configuration file, this one here that you saw earlier, and we'll just write that to a file. Now, we're disabling mlock here just because we're running this example in a Docker container, but you probably want to kind of say you always want mlock to be disabled because you don't want anything to be written to RAM disk, any tokens or memory like that. We're specifying, the boundary cluster ID. Again, that's going to get picked up from our variable that we are loading. The listener is standard. The auth data is as we had it before, and then we're just using that token that we created in the previous step. And that's going to generate our token. Now, the next thing that we want to actually do is to look at the deregistration script. So let's have a look at a deregistration script. You can see what's going on here. Now, with the deregistration script, what we're going to do is we basically want to take the worker that we created in the previous step, and we just want to just shut it down and clean up after ourselves when the machine shuts down, because it'll obviously create itself every time the machine starts if we have that in a systemd startup job. And we can set that here. So again, we're doing the same things. We're just setting we're going to authenticate, and then we're going to call the deregistration URL using the worker ID, authenticate to boundary, grab the token, and then run that deregistration call. And that will clean up after ourselves, and we'll also remove the auth data there, so there's nothing left lying around. For our simple example, because we're not going to be actually using systemd, what we can do is let's just put this at the top of our script here in a trap, and then whenever this script process is terminated, or it receives a sigterm or a sighup or anything like that, it'll automatically call deregister. And that's just because we're going to run this nice and simply. Right, so now we've got everything there. The last thing we need to do in our startup script is we need to actually run the server. So we're going to do, we're just going to basically just run boundary worker server. We're going to specify our configuration that we're writing here. And then we're basically just going to grab the PID there, and then just we can basically just wait on that PID, which will kind of just be our nice little script there. So then we can run it. So let's go over to our terminal and let's run our script. So I'm just going to do run a script startup. See there, it's generating the token for the boundary worker. It has called the boundary API, set everything up, and we can see there now that the boundary logs are streaming in. So I'm going to bounce over to my workers. you can see now there, we've got our boundary worker front end that we've just created. And that's up and running. And that's pretty awesome. So the next thing that we want to be able to do is to see how we can now use this boundary worker and connect to use it to connect to the SSH on that virtual machine. All right, so we've got a boundary worker now running, which is running here. So what we can do is, because this boundary worker is running in the same subnet as our virtual machine, we can actually use it to be able to initiate an SSH connection to that VM. Now, to be able to do that, what I need to do is I need to create a target. So I'm going to create my target. I'm using this command, boundary target, create TCP. The token, I need a token to authenticate the request, and that's just my auth token. I'm going to give it a name. I'm going to call this VM TCP, because we're creating a TCP target. Now, a TCP target is basically just a very dumb target. It's just going to proxy any traffic that you send it to the destination using TCP. There's no cleverness going on here. I'm going to give it a description, and that will kind of show up in my boundary UI. And I'm going to specify the default port. And the default port is port 22, and then the address. So this is the address by which the boundary worker can reference the virtual machine. So it's an internal address, and that for our machine is VM container shipyard run. And of course, we're going to specify the scope ID to which we want to create this in. And then this is the kind of the magic sauce here. So this is the egress worker filter. So the egress worker filter is the worker which can handle this request. If you don't specify the egress worker filter, HTTP is going to try and use the public workers, and the public workers have no access deep into my network to be able to do this. So I've got to specify the egress worker filter, and that's going to be front end. So let me run that. And you can see there that it spits out a bunch of information there, including the ID, obviously the scope is boundary demo, and you can see that inside of the UI as well here. So let's just go here, go to our boundary demo project, and then if we look here, we can see our target, VM TCP. It has all of the bits and pieces. Now you can see here that we're using a private network worker, so an egress worker host, and then the name, which is front end. So the name, it picks that up from the tags, which is on the worker, and that was what we set up in our boundary configuration worker config here, these tags. Right. So we've got that running. Now that that's running, we can actually use that to make a connection. So let's use that and create that connection. To connect over SSH, what we're going to do is we're going to use boundary connect SSH. Now, boundary connect SSH is just a helper. The SSH here is just a helper function. What it's going to do is it's going to launch an SSH session for the target. So the target ID, let me just grab that here, and we're going to run that. And what you can see is we'll run that there. Now, it's just running, it's created that SSH session. So we've got the connection there. Do you want to continue connecting? Yes. Now it's asking me for the password, and the password, well, I don't actually have the password there. So let's run that again. But this time, let's run it and let's specify some additional information. Now what I can do is I can specify some additional information that I want to pass to the connection helper here. And this is basically just the flags that would get added to the SSH command. So I can specify the user as root, and I'm also going to specify the private key, which I've got here in this file, front end files, SSH keys, IDRSA. If I run that now, it's going to make that connection. So that connection is going from my local machine to boundary and HCP, and then it's going to route its way down through the local worker that we've got running here, and then it's going to establish that session.
Okay, so we've been able to make our SSH connection using Boundary, but there's a small problem. We had to specify the username and we had to give it the SSH key. Instead, what we want to do is we want to see how Boundary and Vault can work together to transparently inject that SSH key, which we can get directly from Vault. Now, to do that, we have to change a couple of things that we did already. So we already created a target, and that was a TCP target. But instead, what we want to do is we want to create it as an SSH target. Now, this gives us some magic that allows us to inject the credential at runtime, right? So it's the same kind of command. It has all the same details in there as what we had before. The only difference is we're specifying a type, which is SSH. So we run that and it's created the target just as we've seen before, right? If we head over to the UI and we have a look, we can actually see that we've created a new target. Okay, so now we've created our target. What we now need to do is we need to create the actual secret in Vault. So we need to create the SSH key. Now, how to do that is it's a special type of secret we need to do. It's going to be using the KV secrets engine, but we need to specify two keys in there. The first is the username, which will be root, and the second will be the actual SSH key itself. Okay, so now we've created the secret, we now need to create a Vault policy. And the Vault policy has to do a couple of things. Firstly, it's going to need to be able to access the secret that we've just created. So we have a policy here, which leads to the exact path that we specified for creating that secret, and it gives it read permission. We now need to create another policy, which we're calling the controller policy. Now, this is the policy that's going to allow Boundary to be able to renew its own token and to look up its own details and just generally manage its lifecycle of its relationship between itself and Vault. So we have a few different things here. The main thing is it can revoke itself and it can renew its own leases. Okay, so now we're writing these policies to Vault. And if we could just do a quick lookup just to make sure these policies exist, and we can see we have the controller secrets and the controller token policies. So in order for the controller to be able to speak to Vault, it's going to need a Vault token. So we're going to create a Vault token with these policies that we've just created within Vault. It also is going to need to be an orphan token. It cannot have any inheritance of any permissions of any parent token. One final thing is it also needs to be a renewable token. Like Boundary is going to need to be able to renew itself when the token expires. Okay, so now we've created that token. We can see that in the output where it says client token. So the next step is we actually need to create the actual credential store within Boundary. So we have two types of credential stores. We have a static credential store and we have a Vault type of credential store. We're going to use the Vault one in this instance here. We're going to need to give it some details like address, and we're going to need to give it the token that we've just created as well as some other details. Okay, when we create the credential store, it's important to note that it's actually the controller that is going to speak to Vault in order to obtain the credential. It's not going to be the worker, right? And so as such, we need to think about the connectivity between our controller and our Vault, which is in a private network. So if we create this credential store here, and we hit enter on that, it's going to hang. It's not going to be able to make that connection to Vault, simply because it has no way to be able to connect to Vault in a private network. So in order to do that, what we have to do is we have to specify a egress worker tag. We need to tell it exactly which worker it needs to use in order to speak to Vault in our private network. So if we kill this command here, okay, so when we run this command, but this time add the worker filters and we tell it exactly which worker to use, we should be able to create the store because it's able to make the connection to Vault and it's able to verify the connectivity details. And there we have it. So we have this output here, which shows that it has now created that credential store within Boundary. So now we've created a credential store, we now need to create a credential library. Now, a credential library is just a reference to a Vault secret. We need to tell it exactly where to look in Vault in order to obtain this secret. So here we're going to tell it the credential store ID, which is the one that we've just created. We need to tell it the path within Vault in order to make the call to retrieve the secret. And we also need to give the library a name, right? Now, the credential type that we are using this time is SSH, because we want to inject the SSH credential into our sessions when we do that. So if we just run this command here, this will create our library for us. Now, if we have a look in the UI, we can see that the credential library has now been created. So the next thing we want to do is we need to associate this credential library with the SSH target that we created before. Okay, so to associate the credential library with our target, we need to run this command here. And all we're doing is we're going to add credential sources, and we need to grab a couple of IDs. So we need the ID of the target within this command, and we're going to need the ID of the credential library, which we're calling credential sources. So we'll just grab that and we'll paste that in here and hit enter. And now that has created the association with the credential library. So now if we have a look, we should be able to see that in the UI. If we look at the target, there we go. Now, let's test this out. So if we run Boundary Connect, but this time, instead of us having to specify the username and the SSH key, it should automatically inject this into our session. So when we run the command, we should be straight into the VM. And there we have it. We are in. So what we've done is we've shown how Boundary and Vault can work together to automatically inject credentials into the session, with us transparently not having to know what that credential is.
So I think you'll agree that was some pretty interesting stuff that Rob's just shown you. Now, stay tuned, because we will be back later on with part 2, where we're going to kind of start digging into Boundary and how we can handle things with dynamic workloads in Nomad. So welcome back to our second part. And in this session, what we're going to do is we're going to concentrate on dynamic workloads. So we're going to show you how Boundary workers can integrate with Nomad Scheduler, and how we can actually run Boundary workers in an easier way when they're running in highly dynamic environments. All right, so we've already seen some pretty interesting things, I think. We've seen how we can use Boundary to connect just to a virtual machine via SSH, and how we can inject Vault credentials. But now let's have a look at how we can deal with sort of ephemeral workloads, such as when you're running in Kubernetes or Nomad or other sort of dynamic environments. And we're going to kind of run through this in a couple of different parts. The first is we're just going to show you how to actually run Boundary workers on side of Nomad so that we can provide access to those workloads. And then we're going to kind of tackle a bit of a problem, which is what do you do when those targets are constantly changing? So the IP addresses, the ports, they're running in a highly dynamic environment, then they're always changing. So let's first look at kind of an overview of what we've got. So what we have is a Nomad cluster. Now the Nomad cluster is comprised of a server and 3 different clients here. Now if we want to provide access to any of these applications which is running inside of this Nomad cluster, we could potentially just publicly open that up. Well, that's not a good thing. We could work out how we can kind of get onto the node itself. And then, that again, from a security standpoint, that's not a good way to do it. What we want to be able to do is we want to be able to use the kind of the sandbox security capabilities that Nomad has for your applications. And we want to be able to kind of just be able to inject a connection direct to that without being able to expose any of the other applications running on this particular node or any of the other nodes. And to do that, we can actually use Boundary. We can run a Boundary worker on each of the nodes, which would allow us to be able to define a target and then, create a connection to any of those applications. And that's the kind of the first step. Now, I think the key thing around this is that we ideally want ephemeral workers, right? Because the approach that we've taken so far is that we kind of register this worker. It has a kind of a known name. We're giving it a username and password, which is somewhat static, and that's not an ideal way to kind of go about it. We want to be able to do a controller-led approach in terms of registering our workers, but we want to be able to do it fully dynamically. And to do that, we're going to use a Vault plugin, because there's a Vault plugin which we've written, which enables you to dynamically generate these sort of boundary workers and the the controller-led tokens that is needed to connect to them. So we can use the built-in mechanism that Nomad has to be able to identify a workload. We can use that to authenticate against Vault. Vault then speaks to Boundary to generate the controller token and do the initial registration of the worker. And then, of course, we can just go ahead and start the worker. And it's a very elegant solution, and it's pretty cool, and it works 100% with the dynamic scaling and the fact that a worker inside a boundary is not going to live forever for Nomad. The job could get killed, the node could disappear. There's a number of different reasons why this is highly shifting. Anyway, enough waffle. Let's have a look at the demo and see how this works. What we've got here is a Nomad cluster, and there's no jobs running on this Nomad cluster. But what we're going to do is we want to run a job on this Nomad cluster, and we're going to be able to get secure access to it, even though the Nomad cluster doesn't have any public access whatsoever. So how are we going to go about doing that? Well, the first thing that we need to do is that we need to be able to run a worker inside of our Nomad cluster. Now, to run a worker inside of our Nomad cluster, what we could do is we could go through that whole process that we did before, where we had these kind of startup scripts, and we could have all of this in a job, or actually we could use a Vault plugin. So let's have a look at how we can simplify all of this by using the Boundary Secrets engine for Vault. So to use the Boundary Secrets engine for Vault, what you need to do is you need to first download it, and you can download it from this URL, and then we'll kind of install that inside of Vault, and we're gonna be able to run it. So it's going to be Vault Secrets enable Boundary. So the kind of that standard way of enabling a secrets engine inside of Vault. And then what we actually need to do is we need to configure it. So to configure it, again, like any secrets engine in Vault, we're going to write to the config part of the path. And it needs certain things. So Vault needs the ability to be able to talk to Boundary, in this instance, Boundary HCP. So it needs the address of the Boundary cluster, it needs the login name, and it needs the password, and also the auth method ID that it's going to use to authenticate. Now, in order for this to work, Vault needs sort of fairly permissive control over Boundary, because it needs to be able to create controller-led worker tokens. And the setup for how you configure all of those user IDs is in the script there, which you can find in the README. So we're gonna run this, and just configure it. So this is, again, it's using my HCP Boundary setup here. So we've configured that worker thing. Now, in order to be able to generate controller-led tokens using Vault, what we're going to do is we're going to create a role. So again, this is pretty standard Vault stuff. So I'm going to create a role. I am calling I'm putting out the path, calling the role worker. I'm setting a TTL and a max TTL. So the TTL is going to be the maximum duration that the worker will exist for. So it's going to be 36. That's in minutes, isn't it? Is that an hour? Seconds, yeah. So there's an hour. And then we're setting the max TTL, which is like how often the lease can be renewed. So we're just setting those again to an hour. We're setting the role type. So the role type is worker, and then the scope that the worker will be registered to, which is going to be ID. Now, once I've created that, what I can actually do is I can use it. So if I do Vault read boundary cred worker, and then specifying a name for my worker, and I run that, Vault gives me back an activation token that I can then use to register a worker. If I go over to my Boundary cluster instance and look at my workers, you can see there, we've got our local worker. It's been generated by Vault. And that's all set up there. Now, the nice thing about that is because Vault is managing this, I can actually revoke it. So let's just do Vault lease revoke, give it the name of the lease there. And then if we go back over to the boundary UI and then have a look at our workers, let me just refresh that. You can see there it's gone because Vault's managing that worker instance now, which is really nice. So what we are going to do is we're going to use that with Nomad. So we're going to get Nomad's Vault secrets to be able to generate that worker token that it can then use to start our worker. So in order to create secrets for the worker, again, Nomad is going to need a policy. So let's have a look at that policy. The policy is just going to be called worker policy. And it's going to look like this. So we're going to create this worker policy. And this will give Nomad the ability to generate those credentials. So we need to write that to Vault. So let's do that. Okay, so we're going to write that to Vault. And then what we can do is we can actually create our Nomad job for running inside of Nomad. So let's create a new file. And let's save this as boundary worker. So let's do file, save as worker.hcl. So this is the basic Nomad job. So all it's doing is it's using a very simple setup here. So let's go through and let's build this up. So what we want to be able to do is we want to be able to inject some secrets into this job. So we are going to add the Vault stanza. Now the Vault stanza, what this is going to do is this is going to tell Nomad that it can use this boundary worker policy, and it has that available to it to be able to get some secrets. So the secrets, what we're going to do to be able to use those, we're going to just use a standard Nomad template. So the Nomad template is going to look like this. So let's just run that. And you can see there that we've got that Nomad template. So it's exactly the same as the configuration that we created earlier. I'm just setting the cluster ID there. But rather than having that controller generated secret injected from an environment variable, we're using Vault template here. So we're specifying with secret, boundary creds worker, and what we're going to do is we are going to use the worker name, and we're going to set that to the Nomad allocation ID. So we're using this function here, env, and we are piping that into the template function printf to be able to generate the worker name inside of the template stanza. So it's just a little bit of a workaround to be able to generate dynamic parameters for our Vault secrets. Tags, just setting the environment there in Nomad. And then what we're going to do is we're going to specify our configuration. And the worker config is going to look like this. So the worker config, we're actually going to use the boundary worker HCP 012, and then we're specifying the command, which is going to be server config, and then the path of the config is local config, and that's what we're generating here with this template. So we can deploy that worker now to Nomad. So let's run that. We are going to do Nomad run and it's going to be worker.hcl. So we can see there that job's getting triggered. Let's bounce over to Nomad and let's just refresh that UI. We can see there that we've got the boundary worker. The boundary worker is pending. This is going to start running in just a second. Okay, we've got the task started. Let's just have a quick look at the logs. Brilliant. So you can see there that we've actually got it all connected up. We can see the logs that have streamed in. Let's go over to our workers in our boundary UI, and you can see there that that's our Nomad allocation ID. So the process that we've done is the Nomad template has used secrets from Vault. We've used the boundary secrets engine inside of Vault to automatically generate these controller generated activation token. We've injected that into our boundary worker in our Nomad job, and it's just started up. And of course, whenever we delete this worker, it's going to deregister itself as well. So that is all we really need to do in order to be able to now start being able to access jobs from inside of our Nomad cluster.
Okay, so we've been through the process of how we're going to use Nomad to register our boundary workers in a dynamic fashion. But what about our actual workloads, our actual application components? How are we going to go about handling access to these things here? So if we take a look at our Nomad overview, as we saw before, it's a very simple setup. I'm the job owner, I'm the developer, and I'm going to submit a bunch of jobs. And we have 3 different nodes here. So I have jobs going to different client nodes as per the requirements, right? The challenge here is once we've deployed these jobs to their nodes, how do we access the actual jobs via boundary? And this is where Census comes in, right? So Census is a tool that we're going to deploy in our Nomad cluster, which is going to register all of these jobs as boundary targets. So the way that works is this. We would submit our jobs to Nomad as usual, right? And when Nomad schedules those jobs, Census is going to listen for events in Nomad. And anytime a new job is registered or anytime there's any updates to the IP address or the port or anything like that, Census is then going to contact Nomad, is going to create a target or it's going to update a target with the connectivity information. Or if the job is removed from Nomad, then it will go to boundary and it will remove a target. So essentially what Census is doing is it's taking an event-driven approach and looking for all jobs that we deploy to our Nomad cluster, and it will just register them as targets within boundary. And this will allow us to do some of the similar things that we've seen in the previous session where we're able to create sessions to these workloads using boundary, using local proxies and reverse proxies. Okay, so let's have a look at this problem in practical terms and actually just play this out, right? So we have Nomad here. Let's just run a job. We're going to run the job just to see exactly what happens, right? So we're just going to run this command, Nomad run, and this is going to take the job file and deploy this to one of our client nodes. So here we have the job deployed. Let's take a look at that in the UI. So here we can see the job has been deployed. Now we need to get the IP address and port if we did want to connect to that. So we can find that right here. And that's no good because, you know, if we need to register that in boundary, that's going to change all the time. We're actually registering this in Consul as well. So we can see it's automatically registering that service within the service mesh. But still, there's no way to automatically get that into boundary, right? So you can see we're in boundary at the moment and we don't have a target for this job, right? So how can we fix that, right? And the answer to that is Census, right? So if we stop this job, we can have a look at how we can deploy Census into our Nomad environment and see how this can automatically create the targets for us. Okay, so let's have a look at the Census job file here, right? So the key thing in this job file is this config block, right? So essentially for Census to work, we need to configure a few details here. And we're going to use the same technique we used with the boundary workers using the templating engine, right? So the important thing here is we need to give it some connectivity details for boundary. So as you can see, we have username, password, address, and some other details like org ID and auth method. And the easiest way to get that in is to store these things in Vault as a secret, right? So let's write a secret to Vault that contains all of the parameters that we require. Okay, and that's written there. Okay, so here we have the Vault policy that we need to write to enable Nomad to be able to access these secrets to inject it into the config file. So what we'll do is we'll write this to Vault, just using this command here. Okay, that's successfully written now. Okay, so now that we've got the secret in place and we've got the policy in place, these are the prerequisites that we need for Census. So what we'll do is we will deploy Census as a Nomad job. So let's just run this. And now it's running. Let's take a quick look at this in the Nomad UI. And we can see in the standard out that everything is up and running. Okay, so now we have Census running. All we need to do is actually stop the original job that we had, and we can run it again. And this time Census should spin into life and create the target. So let's run that now. Okay, that is now running. So if we head over to our standard out on the Census job, we can see in the logs that it is registering the target within boundary. And as we can see in boundary, we now have an additional 3 targets, which is 1 for each node that we've deployed there. And that's all being facilitated by Census, which is amazing. So now what we have is this automated workflow that every time we deploy a job in Nomad, or every time an IP address or a port is updated within Nomad, it will automatically keep boundaries target list up to date. And that is pretty cool, in my opinion. It's something that automates the workflow and it just reduces the overhead in terms of managing the relationship between all these different infrastructure components. So now that we have our targets automatically registered within boundary, let's take it for a test drive. Let's try and connect to it in the same way that we did before, right? So we're going to do boundary connect, and we're going to use the target ID, and we'll also enter the token file that we need to authenticate to boundary in order to make this boundary connect work. We'll just run that. And here it gives us a port that we can connect to on our local host, right? So the best way for us to test this is to actually curl localhost and use the port that boundary has given us. So if we just run the curl command, so we'll curl localhost, and it is port 40577, and we should get a 200 response, and we do. And that's actually a response that's coming via proxy using boundary and the workers that's within our Nomad environment. So just to summarize, what we've done here is we've been able to deploy our workloads to Nomad. We've also deployed Census alongside that, which is watching out for any workloads that we deploy into our Nomad environment, and it's automatically registering them as targets to boundary. This then facilitates us to be able to make secure tunnel sessions to our workloads via boundary in our private networks. And that is pretty cool. That's probably the most secure way of being able to access your workloads within a private network.
Well, I hope you found that interesting. I think that concludes our talk for today. But I think we've shown you that kind of you can actually use boundary as a really sort of good way to be able to get secure access to your systems, whether they're dynamic systems like Nomad or Kubernetes, or just kind of like static virtual machines. All of the kind of the example and the source code that we've shown you today, we'll put in the links. You can download this and try yourself. And of course, if there's anything, please reach out to us because we'd love to be able to help you out and chat about those. I think I just want to kind of say a big thanks to everybody who's organized HashiTalk Secure. It's been great to be part of it. We've certainly enjoyed ourselves. I hope you've enjoyed yourselves too. Until next time, from Rob and I, we'll see you all later.